Welcome to the Laboratory of Manufacturing and Sustainability at UC Berkeley. Today's special Cal Day presentation will be a summary of our lab's carbon footprint for the calendar year of 2009. The outline of the presentation will be as follows: background, methodology, results, and finally, carbon offsets. Questions that will be answered throughout the presentation include: what is carbon footprint and how to calculate it? What is life cycle assessment? What is the carbon footprint of LMAS and how does it compare? And how to become carbon neutral. First and foremost, why are we concerned about carbon footprint? Carbon footprint is a collective measure of one's environmental impact. In particular, direct and indirect greenhouse gases produced from creating and sustaining human activity. Typically, represented as global warming potential with units of metric tons of carbon dioxide equivalent. Next, what is global warming potential? GWP relates the efficacy of gases that contribute to global warming to that of carbon dioxide in a given period of time. For example, in a 100-year time span, methane has an effective GWP 21 times higher than carbon dioxide alone. Next, what is life cycle assessment? According to the ISO 14040, LCA is defined as a compilation and evaluation of the inputs, outputs, and the environmental impacts of a product system throughout its life cycle. To better illustrate this, the diagram below shows a cradle-to-grave product life cycle, beginning at raw material extraction, to manufacturing transportation, to the use phase, and finally to the end of life where the product is recycled and/or becomes waste. All the phases play a role in impacting the environment. A widely used LCA method is the Economic Input-Output Life Cycle Assessment, which estimates the indirect environmental impact of one industrial sector on others through economic activity. A more accurate LCA approach is to compute the direct environmental impact. For instance, combustion of fossil fuel to greenhouse gases. Finally, the combination of various LCA methods is considered as a hybrid LCA. To determine the carbon footprint, a hybrid LCA approach with 4 sectors was used. Embodied energy, which includes everything from desks and computers to the carpet and paint. Electrical energy, direct power consumption from the grid. Steam energy, energy to produce steam for heating and hot water. Transportation, which includes both commuting to lab and to business trips, such as conferences. The data for the EIO LCA GWP is provided by Carnegie Mellon, which gives a U.S. average of all major industrial sectors. Embodied energy refers to the energy and resources consumed during the raw material extraction, manufacturing, and transportation phase of a product. The output is indirect greenhouse gas emissions measured in metric tons of CO2 equivalent. To determine the emissions from embodied energy, the product's cost is multiplied by the EIO LCA GWP of that product's industrial sector. The data is given in emissions per US dollar. Note that due to inflation, both the product's cost and economic activity must be of the same year. Therefore, price adjustments may be necessary. An example of desks is given below. Electrical energy refers to the power consumption of a product during its use phase. The output is indirect greenhouse gas emissions measured in metric tons of CO2 equivalent. 2 methods can be used to determine the emissions. The first method uses the EIO LCA data multiplied by the power consumption and the cost of electricity to obtain the GWP. The second method utilizes PG&E's emissions data, which is given in GWP per kilowatt hours. The latter method was used in our analysis. An example with computers is given below. Steam energy refers to the energy required to generate steam for heating and producing hot water. The output is indirect greenhouse gas emissions measured in metric tons of CO2 equivalent. To calculate the emissions, steam, which typically uses natural gas, is multiplied by the steam cost and by the EIO-LCA GWP sector for steam. An example of steam emissions of Echeverry Hall is given below. Transportation refers to the energy required for a transportation mode. The output is direct greenhouse gas emissions measured in metric tons of CO2 equivalent. Determining transportation emissions involves first categorizing transportation modes into land and air. Land transportation takes the miles per gallon and multiplies it by the distance traveled and the emissions per mile, which depends on what fuel type is used. For air transportation, an online carbon calculator was used. Results for the LCA analysis is presented. The total carbon emissions for 2009 was 175.43 metric tons of CO2 equivalent. The majority of the total emissions was due to embodied energy, which suggests that there is significant room for improving the raw material extraction and manufacturing technologies to become more sustainable. Note that the embodied energy is a one-time calculation, therefore the carbon emissions do not carry over to the next year. A couple side comparisons. The first is comparing the results for electrical energy using the two methods, EIO-LCA and PG&E. Because PG&E uses cleaner and more renewable energy than the U.S. average, the GWP is nearly an order of magnitude lower. The second compares the lab's transportation use between land and air. It is interesting to note that the emissions rate by air is 1.5 times greater than by land. So what does 175.43 metric tons of CO2 equivalent mean? Well, you can circle the Earth 20 times by standard gas car, 30 times by plane, 40 times with a hybrid vehicle, or power a 100-watt light bulb for 304 days and 14 hours, or a similar brightness 15-watt LED bulb for 5 years, 205 days, and 11 hours. Carbon offsets is a way to give back to the environment the carbon accumulated. Any individual, business, or organization can purchase carbon credits equal to their carbon footprint, thus offsetting their carbon impact and becoming certified carbon neutral. Carbon credits can be used to help fund renewable energy, reducing overall energy demand, reforestation and avoided deforestation, and many more. In 2007, LMAS became the first UC Berkeley lab to become carbon neutral. By choosing carbonfund.org, LMAS was able to purchase carbon credits that would help fund essential projects for improving both our lives and the environment. We hope you enjoyed our presentation on carbon footprint. For more information regarding this presentation, visit our website at lmas.berkeley.edu.